Students of math, welcome to the law of sines. And I've drawn a triangle here. I'm going to illustrate what the law of sines is. Now you'll notice that this triangle is not a right triangle. It doesn't have to be for the law of sines to work. That's what makes it so powerful. You'll also notice I used capital letters here to name the angles. And then the sides across from the angles, we use lowercase letters to name the sides. Sometimes I use like B to C, something like that, but it's much easier if you just use the lowercase letters. So what does the law of sines say? It says this, that if you take the sine of angle A, and then you divide by the side across from it, that ratio, that proportion is the same for all the other sides and angles. So that's the law of sines. And it's really quite a nice law. It's quite easy to use. So let's do an example. And I think I'm going to try and draw better triangles here using this little straight line drawing feature. So let's see if that does a better job. Look at that. Could have been doing that the whole time. But anyway, it doesn't really matter. So let's say this side is 7. And then somebody tells us this angle is 67 degrees. And someone tells us this angle is 42 degrees. And we're going to try and figure out what is x, this length down here. Okay, so the first thing I notice, it's not a right triangle. So I can't use Pythagoras or I can't use normal trig. So I have to go to something like the law of sines. So I'm going to set this up using the law of sines. I'm going to go sine of angle here, 42 degrees, and divide that by the side across from it, which is 7. So there's one of my ratios. And that's got to equal the sine of 67 degrees divided by x. Okay, so that's really all there is to it. Now that I've set it up, well, I'm going to use cross multiply and divide to solve for x. In other words, I'm going to reach for the calculator, and I'm going to go 7 times the sine of 67 degrees, right? So you go bottom times top, and then you divide that by whatever is left. In this case, what is left is the sine of 42 degrees. So this is what I put through on the calculator. Okay, and if I do that, I did that ahead of time, I got 9.63. Okay, that's the law of sines. It's relatively straightforward. Let's do another example. In this example, let's draw our triangle again. So something like this, maybe up to there, down there. Boy, this line drawing thing makes it easy. Anyway. Let's say I wanted to figure out this angle. We'll call it angle A to keep it simple. And let's say they tell me that angle down here is 20 degrees, maybe this length is 32, and this length over here is 18. Okay, well again, I look at this and I go, this is a non-right triangle. And that's an important observation because that means things like Pythagoras can't use it. Regular trig, like sine, cosine, and tangent, can't use it. Okay, these only work for right triangles. So what have I got? Well, so far, all I have is the law of sines. So I'm going to carry on and set this up. So I go, well, sine of 20 degrees divided by the length across from it, which is 18. That equals the sine of angle A divided by the length across from it, which is 32. Now you'll notice this one's a little bit different from the other question, and that's because we have the unknown is the angle. So when I cross multiply, I'm going to go 32 times that by sine of 20 degrees. And then I'm going to divide that by 18. But what am I actually solving for? That's not giving me angle A. That's giving me sine of angle A. All right? So when I finished doing this cross multiply and divide thing, I worked it out. I got 0.6080. And you can see that's not an angle, but what it is, it's the sine of the angle. So I have to do one more thing. I have to take sine inverse of both sides. So when I do that, okay, the sine inverse gets rid of sine. Now I've solved for angle A. So I go sine inverse of 0.6080, and I get 37.4 degrees. So that's the difference in this question. There was a little extra step because we were searching for an angle. All right, I'm going to do one more example. Clear the screen. Sometimes the given information doesn't include a picture. So sometimes they say given angle A, maybe they give you an angle, and maybe they tell you from B to C it's 12, and from A to C it is 18. Okay, that might be the question, and they might say solve the triangle. Okay, what does this even mean, solve the triangle? Well, it means find all the other ingredients that you don't know. Like, I don't know angle B. Okay, so that's got to be figured out. I don't know angle C, so I guess that's got to be figured out. And there's one side I don't know. Let's see, I know B to C, and I know A to C. So I guess I don't know A to B. So these are the things when it says solve the triangle, it's finding the other missing information. Now, I think you need a drawing. Makes it way easier. So what I'm going to do is draw some kind of triangle, not necessarily accurate, but reasonable. I'm going to start with angle A. So down here I'm going to draw 34 degrees. Just do something like that. Okay? So that's angle A, and I'm going to say, yep, that is 34 degrees. So that means the rest of this I got to fill in with B and C. So let's try to make it look kind of reasonable. Let's draw a line down here. And let's see, B to C is 12 and A to C is 18. This looks more like it would be 18. And this could be B to C is 12. So there it is. It's not perfect, not to scale, but you know what? It's good enough. Now I'm going to use the law of sines because I got nothing else. It's not a right triangle that I'm aware of. So I'm going to start off and set up what I can. Sine of 34 degrees divided by the side across from it, which is 12. That has to hold true for, and we would go after angle B first because I know the side across from it. So that has to be sine of angle B divided by 18. Again, cross multiply and divide. So to get sine of angle B, I'm going to go 18 times that by the sine of 34 degrees, and then divide that by 12. Once I've done that, remember you're going to take this number here and you're going to sine inverse that. So when I did that, this is what I got for angle B. Angle B turned out to be 57 degrees. Now here's the good news. It's now really easy to get angle C. I don't need to do any fancy law of sines or anything, because what I got is I got this guy's 57, and I knew angle A already. So in a triangle, they have to add up to 180. So I'm just going to go 180 minus these two angles. So if I do that, I end up with 89 degrees. Okay, again, where did this come from? It was 180, the angles in a triangle, take away that 57, and take away that 34. Okay, well, I got one last thing to figure out, and that is AB. So I've got this. So I got one more thing to do, and now I'm going to use the law of sines. So let's go sine of 34 degrees, and we're going to divide that by the side across from it. And that's got to equal sine of angle C. So we're looking for side C here, or AB. So I'm going to use angle C, which is 89 degrees. And this one's really nice because I don't have any second step. I just go 12 times sine of 89 degrees, so 12 times sine of 89 degrees, and then I'm going to divide that by sine of 34 degrees. When I do that, I got 21.46. So that is now a solved triangle. And that's where I'm going to stop for now. We'll catch you in a little while.